In this video, we're going to be solving equations using logarithms. Logarithms are actually the inverse function of exponentials, and that can help us solve these problems. The standard form for a logarithm is b raised to the y is equal to x. And from looking at our logarithm, we can plug this information in. Log base 5, which is b, that's our base function, raised to the third power is equal to x. When we have 5 raised to the third power, that means we're going to have 5 times 5 times 5. So 5 multiplied 3 times, which will give us an answer of 125. So that means that over here, x is going to be equal to 125. For this problem, it's going to be something similar where we remember b raised to the y is equal to x. And we can set up our logarithm equation something similar where we would say 2 raised to the fourth is equal to 2x minus 1, which would simplify to 16 is equal to 2x minus 1. So we would add 1 on both sides. This would give us 17 is equal to 2x. So dividing by 2 on both sides, it's going to give us that x is equal to 17 over 2. When we have this positive sign, this actually means a special function where if we have log plus a plus log of b, that's going to be the same thing as 1 log, where we actually multiply a times b with inside. Now this can only work if we have the same log base on both sides, whatever that could be, 10, 5, 2, whatever. So since we have the same log, we can actually multiply these together. So we'd get log base 10 of x times x minus 3 is equal to 2. And we know from our special equation that b raised to the y is equal to x. We can simplify and remove this log base 10 by knowing that we have 10 raised to the 2 is equal to x times x minus 3. And if that's the case, we can put this over here to get 100 is equal to x times x minus 3, which would simplify to x squared minus 3x. And then what we can do is subtract this 100, move it to the other side. So we get x squared minus 3x minus 100, and that's equal to 0. And we would use the quadratic formula, which you can find in another video on how to use this completely. And this is going to give us an answer of 3 plus or minus the square root of 409 over 2. Now this is two answers. We have one value where we have the plus, and we'll have one value where we have 3 minus the square root of 409 over 2. Now this is going to be roughly equal to 11.611 and negative 8.611. Now there is a special characteristics of logs and natural logs, and that's that we can't have a negative value for a log. And that's because you can't have a negative value for a log. So if we take a look at a graph of log, it's going to end up looking something like this. Now it'll always approach 0, but it'll never be 0, and it'll always be a positive value. So if we take this first part of this function, and we have log base 10 of negative 8.611, that's going to tell us that it does not exist. So if that's the case, we cannot actually have this value as one of our answers. So the only value of x that is possible is going to be 11.611, and that would be our one and only answer. For this question, it also has the special property that we can use. If we have log a minus log of b, that's all going to be within 1 log of a divided by b. So for this example, we're going to have log of x plus 5, and with that minus sign, we're going to end up dividing it, and that's going to be equal to 3. Now we have a log base 2 with this information inside, so again we can use the property of b raised to the y is equal to x. So for this example, it would be 2 raised to the third power is equal x plus 5 over x minus 1. Moving this over here, we can start simplifying this. 2 raised to the third is going to be 8, and that's going to be equal to x plus 5 over x minus 1. We would multiply both sides by x minus 1 to get rid of the denominator to help simplify this. So we get 8x minus 8 is equal to x plus 5. We would add 8 on both sides. We'd subtract this x on this side. So we're going to get that 7x is equal to 13. So x would be equal to 13 over 7. Now it's always good to take your answer and plug it into each one of the logs to make sure this works. And for both of them, we're going to have a positive answer, so we could actually take the log of both. So this will be our final answer. So for this question, again, we have the plus sign, so that's going to change this to x minus 4 times x plus 2, all within the natural log, and that's equal to natural log of 15. If we have log or natural log on both sides, they can actually end up canceling out, as long as that they have the same base. So now we're going to get x minus 4 times x plus 2 is equal to 15. We can factor this out to get x squared minus 2x minus 8 is equal to 15. We'll move 15 to the other side. So we're going to get x squared minus 2x minus 23 is equal to 0. And using the quadratic formula, this is actually going to give us 1 plus or minus 2 square root of 6. However, from looking at this equation, x is going to have to be greater than 4 because any value less will give us a negative value, which we can't have. So the only possible solution for this is going to be x plus 2 root 6, and that would be your final answer. Now for this example, we actually have log base 10 with values of 10 inside. So when you have log base 10 and then you have base 10 values, you're really just looking at how many zeros that you have in this function. Well, if we have 2 zeros for this one, this is going to give us an answer of 2. Since we have log base 10 of 10, that's just going to be 1 0, so this will be equal to 1. So this is going to give us an answer of 8 times 1 minus 2 times 2 is equal to x squared. We don't have to follow all the laws of logarithms if we're going to end up canceling them out anyways. So this is going to give us 8 minus 4 is equal to x squared. Then we're going to get 4 is equal to x squared. So x is going to be equal to plus or minus 2. And because x is on the other side, it's not within the logarithms, that's going to be your answer. We'll have x plus 2 and x minus 2. For this equation, since we have the minus sign, we're going to end up having a quotient. So we'll have log base 2 of b squared minus 1 all over 15b minus 15. And that's going to be equal to 1. Well, we know that when we have log base 2 of a number, that's really going to be 2 raised to the first power. So we can simplify this to b squared minus 1 over 15b minus 15 is equal to 2. Now, before we start multiplying, we can actually simplify both the top and bottom of these functions. This is going to be b plus 1 times b minus 1 all over 15 times b minus 1, and that's going to be equal to 2. This is going to cancel out b minus 1, so we're going to end up getting b plus 1 over 15 is equal to 2. Multiplying by 15 on both sides is going to give us a b plus 1 is equal to 30. Minusing 1 on both sides, b is going to be equal to 29. And that will be our answer.